Alright, we'll do the next topic, which is basically signs of the trig function. So it says here, let's just read what it says and then explain what we're talking about. Based on the quadrant location, so remember a coordinate plane has 4 quadrants. First quadrant, second quadrant, third quadrant, and fourth quadrant. So based on where the angle falls, based on the quadrant location of the angle, the value of the trig function can vary. So remember what we said when we were filling up the unit circle, that basically the sine and the cosine is values in the different quadrant is the same, except what actually changes is the sine value. So whatever value for sine and cosine I fill up in my first quadrant gets repeated in my second quadrant, third quadrant, and fourth quadrant, except what I need to keep in mind is the sine. So for example, 30 degrees of pi by 6 in my first quadrant is the cosine is square root of 3 over 2 and the sine is half. And I look at the same 30 degrees or the 150 degrees, which is 30 degrees from the x-axis. It is the same. The sine is half and the cosine is square root of 3 over 2, except the cosine is negative. And in quadrant 3, what do we notice? That both are negative, and in quadrant 4, the sine is negative but the cosine is positive. And that's basically what we are going to be discussing here, the signs in the different quadrant. So one easy way to remember is, in the first quadrant, everything is negative. When I say everything is negative, sine and cosine are negative. So everything is, I'm sorry, I'm going to take that back. Everything is positive. Everything is positive, so all positive. When I come to the second quadrant, it's basically, remember, the sine is positive, because if you look at your unit circle, cosine is negative and sine is positive, so sine is positive. And then if you come to the third quadrant, tan is positive, because both cosine and sine are negative, and negative over negative is positive, and in this case cosine is positive. And one of the ways to remember this is, if you can remember, ASTC, it stands for all students take calculus. So this is one of the ways to remember what is positive and what is negative here. So if I draw a typical 30-degree angle, a 30-degree angle is here, and my cosine of this one is going to be square root of 3 over 2 and half, and this is my cosine, this is my sine, and both of them are positive. Whereas if I come to quadrant 2, the same 30 degrees, sine is positive, so half continues to be positive, but cosine is going to be negative, so it's going to be negative. So basically that's what we're talking about. Okay. Another thing we have to keep in mind is, for me to want to fill up this table, cosecant will follow the same as sine theta, because cosecant is nothing but 1 over sine. So the sign does not change. So if sine is positive, cosecant is positive. If sine is negative, cosecant is negative. Same thing, cosine theta and secant theta will follow the same, because when you're doing the reciprocal, the sign stays the same. 2, when you take the reciprocal of that, is positive half. Negative 2, when you take the reciprocal of that, is negative half. And tan theta and cotangent theta will keep the same sign, so they both club together. So in the first quadrant, sine is positive, cosine is positive, tan is also positive. In the second quadrant, sine is positive, but cosine and tan are negative. In the third quadrant, only tan is positive, so these two are going to be negative and tan is positive. Just another way to look at this whole thing. And in the fourth quadrant, only cosine is positive and the other two are negative. So keeping this in mind, we should be able to look at example 7. So it says, example 7 says, name the quadrant in which the angle theta lies, provided the angle theta follows these two rules. What is the rule? It has to basically follow both the rules. Sine theta basically has to satisfy both the conditions. That's what it means. Sine theta is less than 0. So where is sine theta less than 0 basically means it is negative. So where is sine theta negative? We know sine theta is not negative here. It's not negative here. It's negative in third quadrant and fourth quadrant. That's where this is true. But and the condition is and cosine theta is greater than 0. So we're only looking at third quadrant and fourth quadrant, because we have boiled. So in which of the two quadrants is cosine positive? That's the fourth quadrant. So my final answer is my theta will lie in the fourth quadrant. So let's look at B and C too. Cosecant is greater than 0. That means cosecant has to be positive. That means cosecant is the same as sine. So where is sine positive? Sine is positive in quadrant 1 and quadrant 2. That's where this is true. But then it says cosine theta is less than 0. So cosine theta is less than 0 has to be true, and that is not true in first quadrant, because in first quadrant everything is positive, so it has to be the second quadrant. So it's the second quadrant where both the conditions are true. And the last one is cosine theta is less than 0. So cosine theta is less than 0 where? Cosine theta is negative in quadrant 2, quadrant 1 everything is positive. Quadrant 2 cosine 2 will be negative. So I'm going to write that down. Then come to quadrant 3. Quadrant 3 only tan is positive. That means cosine will be negative. And we know that cosine is positive here, so we won't write quadrant 4. And the second condition is cotangent, which is the same as tangent, same sign as tangent, is greater than 0. Where is that greater than 0? Tangent is positive in third quadrant. So we're looking at quadrant 3. So that is one of the ways to find out how particular theta, which quadrant it lie on if it's given the condition. And this is nothing but, if you look at your unit circle, I'm not going to fill in all of them. You can look at the key and fill in the rest. But if you look at this, all I'm doing is looking at my unit circle and picking out what the values are. For example, sine 150 degrees. So you want to go to 150 degrees. 150 degrees is here. And what is this? Remember, this is cosine, this is sine. What is sine of that? That's half. So this one is going to be half. Let's look at this. Tan 7 pi by 6. Where is 7 pi by 6? So 7 pi by 6 is here. And we want the tan. Tan is nothing but sine over cosine. First of all, it will be positive because when I divide this by this, and it is 1 over square root of 3 positive, which when you rationalize the denominator is square root of 3 over 3. That is your tan. Let's look at a couple of other things. Let's look at a negative one. For example, cotangent of negative pi by 6. How do you find the negative angle? So the negative angle is basically you are going in the clockwise direction and you're traveling. So pi by 6 is nothing but 30 degrees. So you're basically traveling 30 degrees in the clockwise direction. So if I look at this, negative pi by 6 is the same as 11 pi by 6, because from here you're traveling pi by 6 or 30 degrees, so you land up here, and what are we looking at? We are looking at cotangent. So let's find, cotangent is nothing but cosine over sine. Cotangent is nothing but cosine over sine. So it's going to be square root of 3 over 2 divided by negative half. And when you simplify this is 2 and 2 get cancelled, so it's negative square root of 3. So the reason is cotangent is nothing but cosine over sine. So if you look at your unit circle, so the main thing in this, the fact that it's negative basically means from here you're traveling pi by 6 in this direction. Positive pi by 6 would be this angle, but negative pi by 6 is basically this angle. So this is negative pi by 6, which is same as 11 pi by 6, and you can find out the cotangent by dividing cosine over sine. This is filled up in the key. So if you go ahead and take a look at the key, you will know what the values for these are.